Okay, so the last of our little blue checklist items here going to be the service propulsion system monitoring check. So for this, these are the gauges here, 4 gauges. Service propulsion system propellant temperature should be between 45 and 75 degrees Fahrenheit. That's about right here and right here. Very small operating zone. We're good. So if it's 0, if the gauge is on 0, you'll set line heaters to AB. If it's less than 45 but greater than 0, you'll set it to A only. And then if it's greater than 45, you'll set it to off. Notice there's the if greater than 75. That's if you are right at like 43, for example. You have flipped the line heater to A and you do a bunch of burn procedures. There's a point in the burn procedure checklist which you would turn it off before you light the engine because the engine will be super hot. You don't want the heater on as well. You could overheat the engine. Probably not, because the heater is very like low power heater, but you know, you don't need the heater anymore, so you take it off, right? Um, Also the post burn stuff, and they don't want you to forget that the heater's on and overheat the system. Yeah, all of that. There's a reason for it. If you come to the point where the temperature goes above 75 at any point before that part of the burn procedure checklist telling you to click the heater off, you have to click it off. Otherwise, you'll get the overheat. You'll probably start getting, flange temp highlight or something going on. Maximum operating temperature is 75. So that's something to keep in mind. It's really not like an if, it's more like a when type situation. Service propulsion system, propellant, tank, helium pressure. Notice how, oh, that's weird. Before, helium was its own tank readout, like with RCS. That's because it's bladder controlled. But here, the helium literally goes into the propellant tank. So that's why it's labeled in this peculiar fashion. So there's a helium tank, or excuse me, there's helium just occupying the propellant tank. So when the fuel is consumed, the helium pressure will drop proportionally. We've started with a very low amount, so it's tanked up with a lot of helium up to pressure. But say this was like a lunar mission, we start with 100% fuel. If we got down to 23.8, our helium pressure is going to be like super much, like very low down here. And we'd start needing ullage and stuff. So that's why there's lists of maximum operating pressure before the burst disk, goes up here. The burst disk is going to go, but you list the max here because that's the max like that you'd normally expect, but there's no minimum. Same with the nitrogen. Notice the triple function gauge here, helium and nitrogen, but we've got nitrogen systems A and B. So we monitor nitrogen. This time it's a maximum of 2,900. So actually about right here is the maximum. Same with B. And back to helium when we're done. Next part of the check, fuel and oxidizer pressures should be within the green band. That's 170 to 195. Our injector valves should be closed, 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 closed. If they're pointed the other way, like this, instead of like this, they'd be open. We record our quantity of oxidizer and fuel. We record what the imbalance looks like. So we can run oxidizer rich, we can run fuel rich. Most of the time we want to keep it 0 or in this black. We can increase and decrease within the respectable black standard operating zone to balance the fuel levels. So they want to be as equal as possible. The fuel and oxidizer levels, that is. So we want to keep them balanced. There are times where we would unbalance it purposefully to maintain that really to rebalance it, if you will. It's kind of ironic. Oxidizer flow valve primary. We got a secondary as a backup. And then we got a propellant utilization gauging mode, primary, normal, and auxiliary. This is almost always going to be in the normal mode, so just leave it as is. Helium valves 1 and 2 will be auto, and the talkbacks will be barber pull. We have manual control of these, of course, but in auto, when the injector valve opens a minute second later, the helium valve will also open, dumping helium into the fuel tank. So there is a helium tank, and it'll dump right into the fuel tank, and the fuel or the helium pressure will drop then as it burns. So a couple additional things I wanted to talk about. We talked about the line heaters, talked about the helium. The last thing was the
Apollo 7 Houston.
Shut up. The last thing was the nitrogen. This engine burns nitrogen tetroxide and hydrazine, but don't get that confused with this nitrogen readout. That's nothing to do with the fuel. It's a valve actuator. So there's a couple sets of valves in this engine for it to run. You've got the main injector valves, but you also have a pre-valve, also called a pilot valve, on our circuit breaker panel here. And so what happens is when the ignition signal is received, electrical, as you can see, actuation occurs that directs nitrogen into the open part of the pneumatic valve actuator that opens the pilot valve. When the pilot valve is open, it redirects fuel flow from the close side of the injector valves, and yes, I said fuel flow, to the open side of the valve actuator assembly on the main injector valve, and that opens the injector. And when the pilot valve closes, that redirects it back to the close side of the valve actuator assembly, slamming the valve shut. This is done to isolate the fuel from anything electrical. So we've got electrics to allow nitrogen flow. The nitrogen is a non-flammable gas then that's used to interface with the valves that will start the engine ignition, and those are actuated with actually the fuel from the engine. So it's all done as a safety precaution to get the electrical as far away from the fuel as possible. I'm not sure why they decided to have the fuel actuate the main injector valves instead of nitrogen. It could be like a maybe a weight issue. Maybe nitrogen isn't like dense enough, but as pneumatic, you could do it with like enough pressure. So I don't know what the deal with that was. Probably pressure and like weight savings going on there. But yeah, fuel will actuate the main injector valves, and nitrogen will actuate the pilot valves that will tell the main injector valves to actuate. So that was the one thing there. Kind of cool. So that's our last check, and then we'll sort of close out the stuff here. I'll probably make an ECS post insertion config tutorial just as showing where all of this stuff is, anything I maybe think of to talk about. But other than that, the rest of the stuff is pretty simple. I'm not going to explain this. That'll be a part of the actual how to charge a battery like tutorial, so we won't talk about the system test stuff with the battery compartment. So yeah, I'll roll back the save, obviously, because we're way the hell, off schedule here with all the talking, but that's sort of next stuff. So I'll make an ECS post insertion config video after.